turbo engine running.
Absolute genius.
Get this.
Welcome.
This is the show where we bring you
Science.
What that essentially means is
discoveries,
Advances.
Questions. Research.
technology.
Unbelievable.
Without further ado,
This is The Naked Scientists. Hello, welcome to this week's Naked Scientists podcast, the programme that brings you the biggest breakthroughs and talks to the major movers and shakers in the worlds of science, technology and medicine, with me, Chris Smith. On the way, among British people, vapers now outnumber smokers for the first time. From Big Bang to Big Crunch, the new theory showing the expansion of the universe might be slowing down, but what's the ultimate fate? And evidence that our early ancestors 3 million years ago might have excelled at DIY. New data suggests that more people in Great Britain are vaping now rather than smoking for the very first time. The figures, which have been compiled by the Office for National Statistics, suggest that almost 5.5 million people currently vape on a daily basis, and that the number of people who smoke cigarettes is continuing to fall steadily and is now smaller than the number of vapers. Linda Bald is a leading expert in public health at the University of Edinburgh, and she also advises the Scottish Government on health policy.
So these are the annual population survey statistics from the Office for National Statistics that look at smoking. It was the main focus, so smoking in the UK, but also vaping behaviour. And we see that for the first time, the proportion of people aged 16 and older who vape is higher than the proportion of people who smoke. And that's quite a big change. 10.6% of people aged 16 and over currently use an e-cigarette daily or occasionally in Britain, and that's overtaken the 9.1% who are currently smoking. It just shows you, I suppose, two things: the continued success in reducing smoking rates and the continued popularity of vaping.
The crucial question, I suppose, is when one adds together the vapers and the smokers, does that number come to a number that's equivalent to or smaller than the number who used to smoke? Or are we seeing a progressive reduction in smokers, but we are growing a population of vapers, including new vapers who would never have smoked?
We're nowhere near the proportion of people who used to smoke. If you go back to the 1950s and 60s, almost 80% of men smoked. So we're nowhere near that magnitude. What you're seeing largely, so the vast majority of these people who are vaping are ex-smokers. And so that's actually a good news story. But you're right, when we look at vaping amongst young people, an increasing proportion of those, particularly teenagers, so 11 to 17-year-olds, where 1 in 5 of them have tried vaping and 7% currently vape, that's about 400,000 teenagers, the vast majority of those have never smoked. And we've got to keep an eye on the young people, because while the vaping amongst ex-smoking adults is essentially a harm reduction success, that's not the case with young people.
I remember interviewing an epidemiologist in America who, a long time ago, said he was very concerned that this may act as a gateway because his research was suggesting it disabuses young people of their fear of tobacco and smoking-related behaviours. So if you ask them, do you think smoking's harmful? And you look at the people who say very harmful, and then you follow up later and see which of those have begun to vape and what their attitude is thereafter, you see that the ones who become vapers tend to have a lower fear factor for smoking. And he was arguing this is evidence that it potentially is a gateway into smoking. Now, are we seeing that? Are we seeing people who take up vaping actually then going the other way and becoming smokers?
So at the individual level, if you track young people through time, and there are some big cohort studies in the US that do this, you do see that there is a clear relationship between trying vaping first and then subsequently going on to smoke. So you could argue that's the gateway. But the other source of data is the population level data. And the question there is, are smoking rates going up over time in the way that vaping has, or are they going up at all? Because we've had decades of smoking rates going down in young people. And the answer there is they're not. In almost all groups of young people, we see smoking continue to decline. So I think what's going on there is that the individual level, that there is certainly a relationship, but I think it's more complex than a perceived risk, lower risk of smoking. I think it's actually about risk-taking behavior. Young people who are more susceptible to a variety of risk-taking behaviors for a variety of complex reasons, they're going to try vaping and they're going to try smoking. What we don't want, though, is that those young people who go from vaping to smoking continue to smoke regularly. And I'm not sure we've got the evidence to support that. But overall, smoking amongst young people continues to decline.
Now, when I was born in the 1970s, it's like you were saying, I was pretty surprised when I looked at the graph the other day of how many people smoked in populations. It was half the population or thereabouts, men and women, who were smokers. And that is now under 10%. And over that time, thanks to studies like the one that Richard Doll ran from the University of Oxford, we've learned that smoking is one of the worst things you can voluntarily do to your health. It's linked to lung cancer, it's linked to heart disease. But it took a long time to prove causation. We're only in the early days, the foothills of vaping-related behaviour. So where are we in terms of our understanding of the health harms, potentially, that come with vaping?
E-cigarettes have now been around for almost, 20 years, really. If vaping was anywhere near as harmful as smoking, we would have many more markers now of that harm. But we don't know about the long-term risk for people who've never smoked, because the problem is the group in the ONS survey, who are vast majority of them are ex-smokers who are now vaping, any health effects for them are going to be confounded by the fact that they were smokers. So sadly, we need a cohort, probably of young people, to follow up over time. My clinical colleagues who've done research in the lab who looked at the toxicants and carcinogens in cigarettes compared to vapes would say that they're very confident that there will be health risks, but nowhere near the magnitude of smoking. And the main reason for that actually is the combustion, the burning of the tobacco and what that emits. But the reason, I guess, from a policy perspective, the reason the UK is trying to chart this course between what's in the tobacco and vapes bill, which has a lot of new measures to prevent youth from vaping, young people from vaping, with making e-cigarettes available as an option for smoking cessation. It's an experiment, and only time will tell whether we've struck the right balance.
And do you think that the measures that are proposed, as in stopping single-use vapes, bearing down on some of these seductive flavours, tutti frutti and so on, which are clearly marketed at the younger demographic, do you think that will help to avert so many young people going into vaping?
I think it will have a big impact because these are the same measures we use for tobacco. We took away all the advertising. We put them in plain packaging. We put them behind the counter. And remember, in the tobacco and vapes bill, that's a measure. As you say, the descriptors, the flavors, the pricing, those kinds of things. So it's definitely moving in the right direction. And actually, data is supporting this because the ban on disposable vapes has already come in. And even before that ban came in, but after it was announced, so that behavioral expectation people have of a change coming, we saw the use of disposables drop from 44% in January 2024 to 29% in January 2025, just before that ban came in. So I think there will be an impact. Whether it's enough, only time will tell.
Time will indeed tell. Linda Bald there from the University of Edinburgh. Almost 14 billion years ago, the universe began with a big bang, with all the space-time expanding away from a central singularity. In 1998, though, that idea was revolutionised by the discovery that this expansion is actually accelerating. The explanation for this was a force dubbed dark energy, an unknowable, undetectable entity, which provides enough energy to override the effects of gravity and grow the universe at an accelerating rate. Now, this would imply that the universe is set to expand forever until every entity in it is so far apart that it can't interact with any other, what we would call a heat death. But what if this Nobel Prize-winning theory is actually incorrect? Because South Korean scientists have suggested that the measurements made to arrive at the present effects of dark energy might have been slightly off. And if they're right, the effect is that the dark energy driving the growth of the universe might ultimately depower, meaning the universe begins to collapse back in on itself again. I suppose you could say, from Big Bang to Big Crunch. Carlos Frenk, who's a cosmologist at the University of Durham, has been looking at the paper for us.
When you try to calculate what the long-range forecast for a universe is, you immediately find that the determining factor is the behavior of the dark energy. That determines whether the universe will continue expanding forever. The dark energy, as assumed, until very recently is a constant, then the universe will just continue expanding forever. It'll expand faster than the speed of light, which is okay, That it means the universe has a horizon beyond which we cannot see, and as time goes by, the horizon shrinks, and we can see less and less and less and less until eventually our descendants won't be able to see out of our own galaxy. But the long-range forecast for that is very, very dull because everything will decay. The universe will expand and expand and expand and expand. Atoms will decay, and the universe will suffer something that physics elegantly called the heat death. Not a very cheerful ending of our universe.
And is there a counterpoint to that argument then?
If the dark energy is not constant, if, as recent experiments indicate, and there's more than one line of evidence, the dark energy is actually declining with time, eventually it will become negligible compared to the force of gravity. And then we're in business. Then we're in a universe that will expand, reach a maximum size, and then recollapse and end in a big crunch, possibly giving rise after that to a new Big Bang, a cycle of Big Bangs where the universe expands to a maximum size, collapses under the force of gravity because the dark energy stops pushing, ends in a big crunch, and perhaps starts again. To me, that's a much more appealing long-range forecast for a universe. It all hinges on what the dark energy is doing.
And what is the argument being advanced in this current publication that might give us some insights into what's going on?
The original discovery of the accelerated expansion, from which dark energy was inferred, was based on it's a very clever technique, using stars that explode, called supernovae, by a particular type called type 1a supernovae. They have a great property, namely, they're all the same intrinsic brightness, and we know what that brightness is. So when you see it at different distances, the farther away they are, the dimmer they appear. But because we know exactly how bright they are to begin with, we can calculate their distances. This new study, which reinforces a conclusion from a much bigger, completely independent and separate study, argues that the supernovae aren't really all the same brightness, that in fact that the brightness depends on the age, and that requires correcting the original discovery. It doesn't mean the dark energy goes away, but it does mean that the dark energy will be declining in time, leading to a universe that recollapses in a big crunch. People are skeptical because of these discoveries based on only 300 supernovae. It's a small number. But the reason I personally like it is because it confirms a conclusion that a completely separate experiment called DESI arrived at 2 years ago already. DESI stands for the Dark Energy Survey Instrument. Totally different technique. Here we use not a standard candle as the supernovae are, but something else called a standard ruler, also to measure distances. And we've been able to map also the expansion history of the universe, but with a precision better than 1%, whereas the supernovae give you much less precision. But the answer is the same. According to DESI, and we made a big splash in the news 2 years ago, the dark energy is declining, and that then means our universe will not undergo a heat death.
How did they identify that we might have used the supernovae brightnesses incorrectly then? How did they get to the bottom of that, and why do they think their numbers are better?
So the scientific community are by nature skeptics. And so any discovery gets scrutinized. And these people in South Korea decided to look in great detail at a sample of supernovae and try to see whether they could find some systematic that had been overlooked. And so it's through this very painstaking work. They had also some models that indicated that the supernovae brightness would depend on their age. So that's what motivated them. And then they published this result that's made a big splash. Now, this is early days for this work. It will no doubt be torn apart, criticized, and we will see where we are in a few years' time. Of course, we can argue until we're red in the face, but ultimately, what really matters is we need more data, and I'm sure I know there will be more data forthcoming with new telescopes. For some reason, humanity is fascinated by the universe. I'm not surprised, but for some reason, we decided to spend billions of pounds in building telescopes and building facilities and spacecraft. And there are very big, very new, very advanced telescopes coming online that will, I think, provide the evidence in favor or against this conjecture from this paper that we're discussing today.
We know that the universe at present is about 13.8 billion years old. So if it's taken this long to get to the stage we're at, if we now invoke this new idea that dark energy is depowering with time, what does that then give us in terms of the time scale over which the universe may inflate and contract and shrink again?
If I go with the results of DESI, I can tell you how fast the universe was expanding 10 billion years ago with a precision of 1%. That is astonishing. Then, if we then take that result, then what the indications are is that we have a mere 30 billion years or so before our universe finally recollapses into a big crunch. So the timescales are long. The universe has been around for, as you say, 13.8 billion years. It's got another 30 odd billion years to go before it disappears in a puff of not of smoke, but of energy, and perhaps starts again in cycles of tens of billions of years.
Carlos Frank there from the University of Durham.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions.
This is the Naked Scientists podcast with me, Chris Smith. Still to come, the early human ancestors who were also great inventors and, as it turns out, clearly good teachers too. Before that though, an influential report is calling on the UK to secure its place as a leader in the space industry in a bid to bolster economic growth. The Crossbench House of Lords Committee, which is chaired by the former EU policy chief, Cathy Ashton, says the space race shouldn't be seen as the preserve of astronauts, but that rockets and space technology can help to deliver tangible benefits to all Brits.
Already, if you're a farmer, you're relying on space to think about when you grow your crops, when you harvest, and so on. If you're dealing with shipping, these big ships that travel all over the world, well, they use space not just to navigate, but also to know what's happening with their products and produce on board. If you're thinking about the best kind of drugs to help people who are sick, sometimes thinking about making them in space because of the way that space affects how things crystallize. If you're thinking about engineering and so on, all of these different parts of our everyday world, well, there's a space element to it. And I think the more that we understand that and the more that we think, how can we make life even better here by what we do in space, so much the better.
The other big shift that seems to have occurred to someone who's not a space specialist is that we've gone from it being the preserve of governments and NASA, for example, to increasingly a commercial thing where you see independent commercial enterprises doing this. So that presumably opens up a lot of opportunity. If you're a big business and you're based in Britain, you can still play in space.
Well, that's true, but it's also about many other countries getting involved in space, the opportunities that countries have seen, not least because the cost of launch has come down so dramatically. You know, when Apollo went to the moon and those early space missions cost a huge amount, many, many thousands of dollars, well, that's reduced dramatically. So now you're in a position where you can do more in space because it's cost effective, as we call it. It means it makes sense for you to be able to put things in space and use them better. So more and more people have got engaged and involved in that. And that's brought some challenges and opportunities too. For example, what do you do with satellites when they kind of run out of their time? You know, how do you deal with debris in space? And all of these things become also important when you're thinking about utilising space and its opportunity for us here.
What were the main things that emerged though? What were the main findings from the report, the real standouts that you think they're the low-hanging fruit, the things we can't afford to ignore and which would be easy wins and we need to get going on them?
I think there are a number of things to recognise this point about it being everywhere, that it's going to affect everybody and that it's a challenge that brings good things as well as challenges that are more negative. The second is to understand what we're really good at. There were different parts of what the UK is doing or potentially could do. So, for example, looking at getting rid of space debris, we've already got companies really working hard on how to achieve that, making sure that they're able to safely either dispose of satellites that have died or reinventing them, reusing parts and so on, which rather transforms how you think about the utilisation or the use of satellites in space. Then it's about areas where you start to look at what could we do more in space, engineering in space. the potential to have more effective, more energy effective things that you make in space, and being able to do it up there and bring it back to Earth rather than making them here. Medics were talking to us about the possibilities of even growing skin in space, because when you grow something organic on Earth, you have gravity to deal with. It kind of collapses, whereas in space they don't. All sorts of things. So what we will be saying to the government is, look, you've got to make some decisions about how we are going to go forward, what we call strategy. You need to give us the things that you believe are going to be beneficial to Britain, beneficial to the British economy, that we can drive forward with. And you need to decide what they are and how best you can support them for the future.
These reports are very laudable. They highlight important targets, but that's not the same as actually having a plan for how to execute on them. So what's it going to take, and are these realisable goals?
Well, these reports go to government directly, and the government has to reply to them. It's how they relate to Parliament. So the government gets a few weeks to consider them and to come back to us with answers to the recommendations and proposals that we put forward. The more publicity that we get around what we're saying and around the things that we think government ought to think about, well, that all helps to kind of get the conversation moving effectively. We've talked to government ministers. There's a great deal of enthusiasm, I think, for what could be done, and an understanding that this is an area where Britain really does have a role to play. And I think and hope that what we'll see for the future, based on the report and based on the work going on within the government departments and so on, is a real plan coming forward that says, OK, these are the things we want to do, and this is how we're going to implement them.
Baroness Ashton, who chairs the UK's Space Committee in the House of Lords. Well, now to paleoanthropology, and a team at George Washington University has found that our early human ancestors, who lived about 3 million years ago in what's now modern-day Kenya, were remarkably inventive, and they could craft and use stone tools. Not only that, but they hung on to these innovations and passed down the know-how behind making them for hundreds of thousands of years, knowledge that might have subsequently unlocked the ability to develop a much bigger brain. As George Washington University's David Braun explained to me, the findings fill in some very important gaps in our understanding of how tool use and innovation evolved among our earliest ancestors.
What we had prior to our discovery is a series of sort of individual locations or places around the African continent where we have evidence of tool use, and some of them go, pretty far back, almost 3.3 million years ago, but we didn't see a sort of continuity in that behavior over a long period of time. And so as a result, we could easily make the argument that these represent a kind of independent invention of these behaviors several times over.
So do you think you've got evidence in favour of our early ancestors, these hominins from 3 million years ago or so, observing each other and copying and basically passing on ideas, innovations, and so on?
I think that the record that we have is what we might expect from a kind of culture/tradition where behaviors are maintained through observation. And that could easily explain the patterns that we're seeing.
Where have you been working? What have you actually found?
So we have been working in a part of northern Kenya that's right up against the border with Ethiopia, in a place colloquially known as Kubifora. We initially found a few artifacts on the surface made of this material called chalcedony, kind of like a almost milky clear rock, but that rock type, when you break it, makes extremely sharp edges. So when we first found a few of these pieces on the surface, my initial interpretation was that these are quite young. But then once we actually started taking samples to try to understand the age of it, we could tell that the sediments had to be at least 2.6 million years old.
And so have you got a timeline now then? So you're saying 2.6 million was a starting point, but can you show that this spans a long period of time, which would fit with your hypothesis that there was observation, copying, conservation of learning going on?
Yes. In fact, we had found the initial group of artifacts and we excavated some of those. And we started to collect data that could determine the age of those deposits. Some of these were quite old. Some of them were, in fact, older than 2.65, all the way down to 2.75 million. And some of them were younger, going all the way up to 2.444 million.
Where were the starting materials coming from, though?
The interesting thing in this particular part of northern Kenya is that the rivers that are carrying the rocks, these chalcedony type rocks, they are not present in this part of northern Kenya before 2.75 million. We have evidence of rivers, but those rivers aren't carrying any large cobbles or pebbles. And so as soon as those rivers start showing up in northern Kenya, you then all of a sudden start seeing, in sediments nearby the rivers, evidence of these stone tools. So in fact, it appears that early humans know that the rivers are the ones are carrying these rocks, and they're going to the rivers to collect them to actually make them into stone tools.
And so this argues that the river gives them the starting material, they've got the wherewithal, and they bring the two things together, discover that they can use this ideal material to make the right sort of very sharp tool, and then they just keep copying that iteratively over hundreds of thousands of years by the look of it.
Yeah, and that suggests they already had the capacity by the time they got to the river, right? Which is, we've made the argument in the paper that based on what the artifacts look like, that this is actually probably a behavior that actually goes much further back in time.
What were they doing with these tools? Because one argument was always that these animals came along, they had a bigger brain that needed more power, and they got that by becoming meat eaters. And if they're meat eaters, they need tools to get meat, and that meant that the meat begot the tools. Are you saying actually it's probably the other way around? And in fact, they didn't need a huge, great brain to drive wanting to use tools. They embraced using tools, and perhaps that along the way then ultimately enabled them to take further steps up the evolutionary tree.
Yeah, I think exactly the second option is what the data actually supports. Early humans are probably tool users for a long time. They use those tools for a variety of accessing different resources. Some of those are meat. We know, for example, that the tools that we found in northern Kenya were definitely, at least at some point, used to extract meat from large mammal carcasses. We know that because we have the cut marks on the bones, right? But that doesn't mean that that's the only thing that they're using these tools for. And it's probably quite likely that they have a variety of tool use behaviors that they're using the tools for. They could be using those stone tools to make other wooden tools, to open up other resources that we don't know about. And so it's probably a good assumption to suggest that they're, have a wide variety of tool use behaviors. And then once they are able to access meat and higher quality dietary items, that results in what's called an adaptive release. In other words, those individuals with larger brains that, requires more calories, they have the option to do that because they already have this release on caloric intake, right? And so then you can incrementally start increasing brain size because you can keep up with the caloric requirement thereof. And so that is a more plausible scenario, is tool use is actually much earlier on, and it allows for changes in brain size when selective pressures are pushing them larger.
David Braun at George Washington University, and that study has just come out in Nature Communications. Well, that's it for this week. Next time, we're going to examine the science behind weapons of mass destruction. They've been used just twice in anger in the history of warfare. But does Russia's claims of new weapons make a nuclear conflict that bit more likely? The Naked Scientists is supported by Rolls-Royce, and it's also supported by you, who very generously help us out by making donations via our donation page at nakedscientist.com/donate. This is a huge help and keeps the show on the road. Do please, if you can help us and you enjoy the programme, consider making a donation at nakedscientist.com/donate. I'm Chris Smith, thanks for listening, and until next time, goodbye.